All right, everybody. Today we're going to be learning one of our last new lessons, and this corresponds with section 12-1 in your textbook. You can see the page numbers are listed there, so you can go through and read that section in your book. There's also a 12-2 section in your textbook, but we're not going to be going through that just because um, that's probably not going to come up on the AP test, so it's not really worth our time to learn the 12-2 lesson. But 12-1, which is what we're going to go through today, does come up, so it's important that you understand and know this. And as we're going through this, again, like we did with the two proportion unit and two mean unit, make sure that you're trying to think about how the stuff we're learning today corresponds to everything that we've learned so far this school year. So it's really what we're doing today is just combining stuff from what we learned with confidence intervals and significance tests to what we learned in Unit 3 with regression lines. So what we're going to be doing today is learning how to construct confidence intervals and do significance tests for regression slopes. All right, so the first video is just going to kind of go over some of the brief kind of formulas that we're going to be using. So first, for a confidence interval, we take our sample stat plus or minus our margin of error. That's like our standard formula. So in this case, we're going to be using our regression slope. That's what we're going to plug in for the sample stat. And then our margin of error, which if we look down here, remember margin of error is going to be your critical score. And we're using critical t-score for regression slopes. So for today, we're only using the critical t-score. And then you take your standard deviation, or another way of saying that is standard error. And you multiply those two together to get your margin of error. Okay, so that's how we're going to construct the confidence interval for the regression slope. Also, want to make sure, just like it says here, your degrees of freedom is a slightly different formula for this. It's going to be your sample size minus 2, rather, when we're dealing with just one proportion, or one mean and two mean tests, it was sample size minus 1, but for regression, it's going to be sample size minus 2. Now, if we look at our test statistic, remember it's your statistic minus parameter divided by standard deviation of statistic. So what that's going to look like is we're going to take our sample slope. And what this lowercase b symbol represents is the slope from your sample, which is what we have for our regression line. So whatever your regression line comes out to, the slope for that, that's what we're going to put on top for our statistic. And then for our parameter, that's what we're comparing it against. And most of the time, that is going to be 0, okay? Because we're going to see if there is a positive or negative relationship. So if our slope's positive, that means there's going to be a positive relationship. If our slope's negative, it's going to be a negative relationship. So if there was neither positive nor negative, then it would just be 0. So that's why we're going to put that in for that parameter. Then your standard error is going to be given to you in your computer output table. So that's going to be easy for us to calculate. You're going to find these are actually a lot easier to calculate because they give you that standard deviation, standard error automatically in the problem. We do have a fair amount of conditions that we need to check. But again, if they're asking you to do this like on a free response question, you just want to kind of write out the conditions and then quickly just do a quick check on them. If they're having you do the whole question, they're not going to, one of these conditions is not going to prevent you from doing it. So you just want to make sure you show them, you know what the conditions are. So the first one is linear. So we want to look at the scatter plot or the residual plot to tell if it's linear or not. Independent, you want to make sure that the individuals, the selections are independent from each other, which that means when you select one person from the sample, it's not going to affect the next person that you select. So in case if you're dealing with like people, you wouldn't want to have the same person selected twice. So that most of the time is going to be kind of just naturally part of the problem. Okay, so you can usually assume that's going to be independent. Normal, to determine if it's normal or not, you want to look at a histogram or scatter plot of the residuals to see if it's approximately normal. If they don't give it to you, you can just assume that it's normal. You don't have to go through and graph out a histogram of the residuals just to check that one condition. On these problems from the textbook that we're going to be doing today, they don't show you that graph, so we're just going to assume that it's met. But on the AP test, they're most likely going to show you that histogram, so you can say that looks approximately normal. Equal standard deviation, that basically means that your residuals look like they're evenly spaced off vertically from left to right, which I'll explain in the next problem. And then we want to make sure that our data points are selected randomly. So we want to make sure we have all those conditions. So those are kind of like the basic formulas and conditions that we need to know as we're going through and starting to solve for the confidence interval and the significance test. So next video is going to be going through the first example problem.